Ever wondered how critical software, like the kind used in airplanes or hospitals, gets made without major bugs? A lot of it comes down to a special process called the V-model. So, what is it? The V-model is a software development method where every development step has a matching testing step. Picture the letter V. The left side is for building the software, and the right side is for testing it. This model is a major upgrade from the old waterfall method, where testing only happened at the very end. With the V-model, we plan for testing right from the start. This helps catch mistakes early, which saves a ton of time and money. It's no surprise it's a favorite in industries like healthcare, finance, and aviation, where getting things right is absolutely crucial. Let's break down how it works. Imagine you're building custom software for a client. First, you gather all their requirements. Then, you design the system, picking the right technology and outlining the architecture. After that, you'd write the actual code. Finally, you test, deploy, and maintain it. This is the classic waterfall approach. But here's the problem with waterfall. What if you find a major flaw during that final testing phase? Going back to fix it can be incredibly expensive. The cost to fix a bug skyrockets the later you find it. It's like the old saying, a stitch in time saves 9. This is where the V-model shines. It pairs each development phase with a specific testing phase. The left side of the V is the verification phase, which is all about building the product right. It starts with business requirement analysis. Then we move to system design, architectural design, and finally module design, getting more detailed at each step. At the very bottom of the V is the coding phase, where the software is actually built. Now, as we move up the right side of the V, we enter the validation phase. This is about building the right product. Each step here corresponds to a step on the left. So, after coding, we start with unit testing, which checks the smallest pieces of code against the module design. Next is integration testing, which ensures all the different parts work together as planned in the architectural design. Then comes system testing, where the entire application is tested against the system design. And finally, we have user acceptance testing, or UAT, where the client confirms the software meets their original business requirements. See how it all connects. The core principles of the V-model are simple. Start big and get detailed. Ensure every requirement is testable. Test early and often, and document everything. This structured approach has some big advantages. It's great at catching defects early, provides a clear roadmap, and improves communication between developers and testers. It's perfect for projects where quality and compliance are non-negotiable. However, it's not a one-size-fits-all solution. The V-model is quite rigid. If requirements change midway, it can be difficult and costly to adapt. This makes it less suitable for complex projects that are expected to evolve. For those, an agile approach, which focuses on flexibility and iterative development, is often a better fit. So, how do you choose? If you're building something for a regulated industry with stable, well-defined requirements like an electronic health record system or a flight control system, the V-model is a fantastic choice. For a dynamic web app with changing user needs, Agile is probably the way to go. In the real world, you'll see the V-model in action in many critical systems. Think about the software that runs an MRI machine, a bank's online transaction platform, or even the airbag system in your car. In these cases, the rigorous verification and validation of the V-model ensure the software is reliable, safe, and does exactly what it's supposed to do, every single time. To sum it up, the V-model is a powerful framework that builds quality into the software development process from day one. By pairing development with testing at every stage, it ensures a highly reliable and well-documented final product. While not as flexible as newer methods, its structured approach remains a gold standard for projects where failure is not an option. Thanks for watching. If you found this explanation helpful, don't forget to like, share, and subscribe for more insights into the world of software development. See you in the next video.